Dobra, witam wszystkich i prosiłbym już o uwagę, bo zaczynamy spotkanie, zaczynamy 59. Pykonik. Już się nauczyłem po, może nie 59, ale po kilku Pykonikach, żeby zadawać jednak to strategiczne pytanie. Do we have any only English speaking people here? Yeah, there are a few. So I will switch to English. I think that one of the presentation is in English, one in Polish, but hopefully the slides will be pretty straightforward. Nevertheless, welcome to the 59 Pykonik meeting. Just to confirm, does everyone hear me well at the back rows? Is it fine? Can we make it a bit louder? Oh, okay. Was that better? Did you hear that? Okay, maybe not that loud. So let's get straight into what will wait for you. I'm glad to see all those faces today. So what will wait for you on the 59th Pykonik? First of all, we're starting with presentation by Karol. I know that you were expecting a different title. It's not a mistake on our side. There was a small last-minute change, but this topic probably would be even more interesting. I don't want to say that the other won't be, but this gives us the opportunity that Karol can speak again on the next Pykonik. Then we will have a snack break, about 20-minute snack break there at the back, and after a quick 20 minutes break, we're coming back with the second presentation from Michał, the presentation called Gimme My Money. After that, we're having lightning talks and competition. Does anyone here doesn't know what lightning talks are? Okay, so everyone knows or everyone is shy. Nevertheless, I will explain that very bit. If you have a topic that you would like to discuss with everyone else, create a quick 5-minute presentation about anything, an interesting library, interesting project, any other meeting that you attend to, you can stand here, take the microphone, take the screen, and share something interesting with everyone else. So the question is, do we have anyone interested in running a lightning talk? Yeah, one person. You can think about it. You have nearly 2 hours to think about it. And if you'll see about something interesting to say, just catch me during the meeting at any time. And there will be a competition with prizes. The people who attend to every Pykonik might be used to the prizes being PyCharm licenses, but today it's different. Today there is a different competition because you can win, the free first person would get a special voucher on Udemy or Empik. So there will be something different with the prizes, but the competition will be nearly the same. I will say something about the competition later on. And after that, we're having a reservation here in Techies for the after party. So this Pykonik is different in many ways. Another different thing is that we don't need to walk for 20 minutes to get a beer after the meeting. We can just stay here, which is quite great. Now I'll get to the thank you part. There are quite a few thank yous that I wanted to say. The first one is about our sponsors. The thank you to both Codete and Techies for hosting us, for having free drinks and free snacks during the meetup. I hope that everyone got their vouchers. And Karol will say a few words about Codete and Techies. And let me switch to this one.
So it's my turn, right? All right, so just let me take my stuff here so I can easily switch. Oh, okay. Okay, cool. So just a few words about Codete. So we are here. Here's the headquarters of Codete here in this building. Yeah, okay, cool. So I have founded the company about 12 years ago. Now we have 3 offices. The headquarters here in Krakow. We have also an office in Lublin and another one in Berlin, in Germany. Most of our customers actually are from the DACH region. Now we have around, I think 350 is outdated. It's closer to 400 people now that we have, with the majority of senior or above level of seniority. What else? Yeah, several projects. All right, in different technologies, starting obviously from big data, data science. So this is actually my domain. My domain specifically is machine learning in the healthcare, in medicine. But that's not the major or main part of the company, something that we do. We also do several other things like cloud computing, DevOps, and just typical web backend and mobile development. When it comes to languages, well, there is a variety of languages that we do, starting from PHP. Actually, we started with this technology 12 years ago. Now, actually doing some Scala, JavaScript, and many, many other technologies as well, and obviously Python as well. Just to mention a few customers that we work with, for example, Deloitte, BMW. Some of them I cannot mention, but I can tell that we are working with the big brands, many of them, but also startups. Most of the startups actually coming from Berlin or the Silicon Valley. So different branches, different industries that we work with. Yeah, if you want to become a contributor, ask us. You can also find me after the presentation somewhere here, and also our folks, our colleagues here, so you can ask about open positions we have currently. Yeah, and Techies is, that's our restaurant, our technology place. I mean, a place where actually we started it about a year ago now, and we are running several meetups, a few meetups per week. Just this week, it's about the third meetup that we are organizing, technology meetups. So feel free to join us here. Today we have Python, we have Pykonik, we are hosting, but there are different technologies that we also hosted already and will host also in the future. Not this way, not this way. Yeah, so if you have any questions, find me somewhere after my presentation, and thank you for now.
Huge thanks for the comment.
And the beer is there, obviously, right? Not so far away. I recommend you all of the craft beers there, very nice ones. Unfortunately, I need to drive today, so I cannot grab a beer. Not today.
Okay. Thank you. And now we're moving to our second sponsor today. Thanks to Talixo, we will have the competition with different prizes than you're used to. So as I mentioned earlier on, there will be free vouchers to give away for Udemy courses or for MPIC, up to you to decide. So hopefully there will be no, oh, I already have a PyCharm this day. So I can't see the person. Oh, here you are. Okay. So the microphone is yours.
Hello, I'm Mateusz. I work in Talixo for a few years. When it comes to the business we do, we are a global operator or pre-book transfer products. In simple words, we join travelers that know in advance when and where they are going to go with the local fleets. Thanks to that, we are able to provide these fleets as many reservations as possible and use their vehicles as much as possible. And to the customers, of course, some attractive and good prices. All we do this, all of the stuff we do with the technology. Our application is built with Django, and this is why we are here, why we are connected with Pykonik and PyCharm and Python network society in Kraków. So if any of you work with Django, would like to share some thoughts, some experiences, then me, Adrian and Marysia, who works in Talixo, are here. So this is all. Have a good meeting.
Okay, and last for today, thanks to Clark. These are these guys. So I think they're quite busy. I don't know if anyone from you wants to say a few words. Okay, they're really busy because the meeting today is being streamed online. It's right now on YouTube. And that reminded me about two things that I always forgot to mention. So first of all, I wanted to say welcome to everyone who is watching us online today. And the second thing that I always forget is that to introduce myself. So my name is Kuba and I'm hosting this meeting today. I always forget about it. Do you want to say something about Clark? Okay.
Maybe not about Clag, but ask for a favor for the audience. If it's possible, please do not use heavily Wi-Fi because this is only connection that we have to stream. So if you download some big files, it could disrupt the stream. So for the competition, of course, but if you don't have a need to use heavily Wi-Fi, please don't do that. Thanks.
Okay, and another thing that you didn't mention, but it's worth to remember about later on, if you have any questions during the presentation, it's fine to just ask them and the presenter would repeat the question, but after the presentations, I will be handling the microphone. So just raise your hand and I will come to you, give you a microphone for asking the questions. And last but not least, we have a Discord channel. We used to have Slack. If you're still on Slack and you believe that it's the only source of communication and suddenly no one is responding to your messages, then you're doing it wrong because we have all moved to Discord. So right now you can join us on discord.pykonik.org. There are quite a lot of interesting topics and quite a lot of users, and I believe that is a good place to join if you want to be up to date with Krakow's Python community. So just discord.pykonik.org. And I think that's it from my side. So I will be giving the microphone to Karol, our first presenter. So we'll give him like a minute for a setup. And let me introduce you all to the presentation about JavaScript, Python, and Cancer. So it's quite an interesting trio, let's say. But there is one good in the trio, hopefully.
I know you expected actually my MLOps presentation. I hope I can actually give it during the next meetup. I didn't want to actually give you a half-ready presentation. For some circumstances, I couldn't actually finish that. But I have another good topic for you: cancer. I hope you like it. So how to beat cancer? I did the same presentation at Meet.js. They didn't like it too much. Because, as you know, JavaScript is a language like it is. Everyone knows how it works and how it doesn't work. So why actually cancer? Why the topic of cancer? Just to give you a better understanding, just to give you a few words why I actually came to that. I did a PhD many years ago, and my topic was about skin cancer. So skin cancer detection with devices like this one. Right? If you go to a dermatologist, they might have a very similar one. I have 3 of these. I mean, different ones. But I'm not a medical doctor, obviously. Just a typical one. And this is actually how I came to our solution. Okay, how to commercialize that? Because writing scientific papers, that's one thing. Maybe it's not an easy job, but that's something that actually I did. You can find some of my papers at Google Scholar, for example, and most of them will be related to machine learning in medicine. But I thought, okay, how to commercialize this idea? How to make it that the doctors will really use that. And this is actually how I came to the presentation today. So I work in dermatology, in skin cancer analysis for about 15 years now. I will show you some nice photos with cancer. You will see. You can imagine I saw thousands of such images, and probably I also see some of you are in the risk group, so you can use this one to check. But I saw thousands of some images, so probably I can already set out a diagnosis just based on the image. But the thing was, okay, how to actually approach the doctors to them to use that. So currently at Codita, we are developing a brand new, totally a prototype for now, dermatoscope with AI in it. We do it in a cooperation with a German company. They have invented dermatoscopes, you can imagine, right? But they don't have AI yet. Together with us, they will provide a new dermatoscope with AI on it. I have also prepared a Docker image for you if you want to play with JavaScript and Python libraries on this topic. There are some notebooks that I have on GitHub, also a Docker image for you with all of the JavaScript libraries. It's not easy to set it up. For Python, it's clear, just few commands, that's it. But for JavaScript, it's a bit more tricky. So I did it for you. And this was my idea when I started my PhD, when I finished that, to sign a contract with a company. We did that. But before that, we have prepared, let's say, kind of a demo, a POC, a demo application to recognize cancer. Cancer, like different kind of cancers, because there are different kind of cancers when it comes to skin. And we use the ISIC archive dataset. You can imagine, when I started my research, I came to my colleague at the university and I asked, okay, look, give me your data. I will just do my job, build the best model possible. So they gave me 56 images. Well, that's just nothing, right? You cannot do any kind of publication, any kind of paper, any kind of research on 56 images. That's not really possible. It was 2007 around. So what I did, I spent 1 year going to every dermatology clinic in Krakow to find a doctor who will share the images. After 1 year, I found one clinic. They gave me 5,000 images. You can imagine, my colleagues at university, I came back to them after 1 year. Look, I have 5,000. Let's do something together, right? Now, for you, it's easier because you can go to isicarchive.com and download more than 60,000 for free images of different kind of skin moles. So it's much easier now than it was before. That's clear. And one of also the, let's say, the argument of why I wanted actually to commercialize that is obviously to fight this sin. I know I don't look like a person who is in the risk group, right? Because I'm I'm not blonde, right? First thing. So this is actually the first thing that makes you okay, I will not tell it, but okay, if you are blonde, blue eye, then you are in the risk group, okay? Of getting skin cancer, the melanoma one, okay? Yeah, I know what your colleagues, friends, right? Who is he blonde with blue eyes? And if you expose to the sun, become pink, then you are for sure in the risk group, right? So be aware and use the cream when exposed to the sun. So the POC that I did, in the first version, you can imagine there was no React Native at that time. There was no TensorFlow.js. So we started to combine that. We used PhoneGap, Cordova for some really crap JavaScript libraries for mobile applications, because as you can see, this is our dermatoscope, right? You can plug it out. Okay, I will do later, but you can, believe me, there are two parts. This is an iPhone, and this is the dermatoscope, okay? Together, you can build an application to really investigate the moles. So, oh, okay, I have more of these, if it breaks. So the first thing, something that we did with PhoneGap, it looked more or less like that. Yeah, not fancy UI. And just some simple assessment like the asymmetry of the mole, border irregularity, color, and so on. So very, very easy to manage. As you see, it was a web app. I know you can develop Android apps and iOS apps with Python, right? Using Briefcase. There is a library to build multi-platform mobile application with Python, but it wasn't available at that time, really. So now it's easier again. So what I did, we have to develop a very simple POC. Then we moved to React Native, what is actually now, using the TF.js React Native library and TensorFlow.js. I guess everyone knows what TensorFlow is, right? It's a machine learning, one of the most popular machine learning library. And everyone knows that Python is leading when it comes to languages with the most major machine learning libraries. So that's clear, right? So that's not something that I need to explain. So why JavaScript? One of the reasons was that actually I was able to develop our application here. So, and that's one of the reasons, right? So how to deploy it really on the application. But JavaScript is not the first choice usually when it comes to any kind of machine learning related projects, right? That's not a surprise. The first choice is obviously Python with the most major libraries, or maybe in some cases R. But everyone that I talk with that is actually doing machine learning, they laugh about R, sorry, but they don't really take it seriously. Most of them actually do Python because R is more like, I mean, you can do machine learning with R, but actually it's more related to statistics, really. Sometimes you actually do Java or Scala when you obviously use Spark, for example. But still, you can even there use Python with SpicePark and so on. And yeah, so this is what I did. On the other hand, you can easily use JavaScript on the web or on the mobile. So the next thing, MLOps, so the tools that I was about to talk about, it was a plan for today. So the tools that are related to MLOps or MLOps tools like DVC, for example. So what we have done two types, or we were able to do two types of applications. First of all, to have the model in the app locally on the phone, and second, to have a service on a web, on Lambda, for example, and then connect all of the requests to the service, and then get a prediction. So in this case, obviously, it's more complex because you need to be connected to the internet. So it's most difficult. So we actually took both with some retraining and uploading with the app. What is MLOps about? It's more about deploying, versioning, monitoring, and deploying machine learning models. Right? Something that I hope I will talk about next time in Python, obviously. So there are different kind of, I mean, it's a mix, right, of DevOps and machine learning. All right. Let me show you some code. Here we go. I did this presentation, you can imagine. It was a bit modified in Kharkiv, in Ukraine, some time ago. So I will just go through. If you know Python, you know pandas, you know NumPy, right? This kind of libraries. That's something that is typical one. You can imagine you have the same in JavaScript. You have pandas.js, pandas, dataframe.js, data4.js, for example. It works like that if you want to have a series or a matrix. It looks like that. Doesn't look similar, and Jupyter Notebook doesn't work perfectly with that because, well, the printing looks ugly, let's say, compared to NumPy or pandas, obviously. But anyway, still, you can do that. Does it compare to the Python version? Obviously not. Well, you heard about this joke about JavaScript, that every week there is a new JavaScript library, right, popping up. That's also true when it comes to machine learning JavaScript libraries. If you check on NPM, there are more JavaScript libraries for machine learning than in Python. Yes, but, well, most of them doesn't work. I mean, most, like 95%. Someone just wrote something, just a small piece, just simple method, push that, and no one cares about it anymore. So obviously you cannot use that in production. Pandas.js or pandas in JavaScript is more or less not, I mean, it's not so bad, really. When you do the calculation, you can do some data. Obviously, you can find the notebooks on my GitHub account. So if you don't follow, feel free to check that. So you can do also some filtering, similar like to Python. Limitations, it's still just a piece of what actually Python gives you. I mean, the pandas, original one. What is good in JavaScript, that in my opinion is better than it is actually solved in Python, are the chart or visualization libraries. For example, D3.js, React Viz, and plenty of, many other libraries that you can use. And I think that's done better than in Python. Especially, if you take a look on Matplotlib, they took it from MATLAB. It's not so convenient to really use that. I mean, I know there are some different ones, but still, I think when I compare, they do a better job because they are, fronted. What is interesting? One, two, three. All right. Sorry for that. Don't worry. It's good that a projector is working. Once I actually, it crashed. One. Oh, okay. That works. So I have no skills to turn it on, right? Okay, cool. All right. As I mentioned, scikit-learn is actually the most popular library for machine learning at all. Doesn't matter what kind of language. Why? It's a bunch of shallow methods. So not deep neural network, but shallow methods. That most of the actually cases are solved with shallow methods, so that's why scikit-learn is so popular. But if you take a look on scikit-learn libraries for JavaScript, you have JS skit-learn, scikit-learn JS, and so on, and plenty more of other ones. But the newest one was last time updated a year ago, and the second one 5 years ago. You cannot rely on that, obviously. So TensorFlow.js, everyone knows what TensorFlow.js is. Do you remember what is this kind of a function here? What do we have here? Can you give some prizes for that? What's here presented on this graph? No. It's in TensorFlow. That's in TensorFlow. These are tensors. Okay. What kind of function is that? It's a very easy question. Statistics. Yeah. That's not a neural network. No. I'm asking about the math. Okay. It's a linear regression. You didn't know that. That's a basic machine learning method and statistic one. Okay. Right. Y equals to bx plus b plus w, right, plus y. Easy as that. Anyway, this is how TensorFlow works. So having some pieces and combining them together. Anyway, TensorFlow.js, that's the only, really only major library for machine learning in JavaScript. The only one that works, right? So TensorFlow.js, TensorFlow in general, is not developed. I mean, it's not a Python library purely. The back is actually written in C++, but we have some, let's say, front-end parts that actually allow you to use the functions. And the first one and the most major is developed in Python. That's why everyone uses Python as well. But there are some other languages where actually it can be used. One of it is JavaScript. So again, if we combine that, we do it similar in Python actually. Here, the linear regression, right? It will look like that. So this is the whole calculation. Just so I can see that, the slides again. So the prediction here, right? You can check if it works here, train that, and do the prediction. The thing is that in these days, even most of the problems are solved with shallow methods. We still have neural networks that became more and more popular, or become more and more popular, like this one. Anyone know what kind of network it is? Autoencoder, perfectly. Great. We have the encoder part and decoder part, and the zip file in the middle. Right? I mean, zip file, obviously. And as everything in JavaScript, there is also Keras.js. But it doesn't work. I mean, it works to some degree. You can load the model, run it, fine, but nothing more than that, really. So it doesn't work like in Python at all. So just to summarize, yeah, some of my trainings here. Please, it's quite easy. If you want to compare, you can obviously go here to this GitHub. You have the same written in Python, just to compare, right? If you want to, here, data frames, visualization with, this case, it's matplotlib, cburn, and so on. So the same thing, but it looks better because Jupyter Notebook works better with Python in general than compared to JavaScript. Okay, so just going back to my presentation. Here we go. All right, some nice pictures, finally. We have 3 moles here. Which one is cancer? My left or your left? Your right. My right. This one. This one. Okay. So what about this one? This one is a cancer. Okay. And what about this one? Actually, you have wrong. This one is actually not a cancer. These two here on the left and right are cancers. You can see it easily because the asymmetry on the left here is quite huge, right? You have stripes, you have dots, so you have many patterns that actually are specific for cancer, for melanoma. And here you can see the blue color. That's very bad because it's going deep in the skin, so it means it's very advanced. I know, you don't know that. I know that because I saw thousands of such pictures. So this is a bad example of a cancer. So, going next. I have more of such pictures, don't worry. I will show you later. Even worse than these. So, how the doctors really do that? So how we did that based on what actually the doctors do. So what they do, they have some different kind of scoring methods. Well, if you go to a dermatologist, they will not talk about any kind of a scoring method. They just look, oh, cancer or not, right? They will just see it because of the experience. But when they learn, when they train at the beginning, they learn different kind of, let's say, scoring methods. So like ABCD, like asymmetry, border irregularity, the color, the number of colors. We have 6 colors, right, that we can find on a picture, and differential structures. So different kind of patterns. Together we have more than 30 different patterns specific for skin cancer, for melanoma. And there are different kind of, based on different kind of patterns, different kind of scoring methods. So what we did, we have automated a hunter score. Why? Because that's the only one that works on multispectral images. Typical dermatoscopes like this one, use the visible wavelength of light, like this one, right? Just a regular one. What we did, we used a dermatoscope with different kind of wavelengths of light to see what's in the skin, not just what you see on the top, but what's inside of the skin. Here you can see the collagen cells that were reacting to different wavelengths of light. Here and here you have infrared. All of them are actually cancers in this case. You see the dots here, you can see the vessels here, and there is also a lot of hemoglobin in one place. That's bad, right? But we did it, so we did a much more complex than typical dermatologists do. Oh, if you want to learn more, there is a link to my PhD, 120 pages, but it's in Polish. Sorry for that. So you can learn more about this kind of images and also learn some Python code here as well. So what we did some image processing, obviously using some image pre-processing scikit image library, for example, to find out the patterns, like for example the border structure using fractal methods, for example. Like here, you can see, oh, it's not regular, right? So it might be a cancer. Actually, in this case, it's not a cancer. But if you measure different kind of patterns here, you might find some that tell you that it's 100% cancer. All right, let's go to the main dish. I still have a few more minutes, right? Let me show you how we did that. I mean, not everything, but just part of it. Here we go. It's fine. I mean, I would just not go through and check every once more. So I still have free hands. So asymmetry checking, for example, as for our PyData Berlin event. Here we go. Nice one, right? So what we did, we have first of all extract what's our interest, so the part of the mole. As you can see, we use the ISSC images here for this example. Another one, definitely a cancer. You can see here, blue, right? That's bad. Or here, more examples. So what we did, we created some kind of a regions to make a symmetry, right? So we flipped that to check the symmetry. And there are 8 parts of this puzzle, let's say, and checked how it works to the number of pixels of the colors specifically. So this is how it looks like then, after that, right? The symmetry factors. Or another one, is this a cancer? It's not a cancer. It looks bad, but it's not a cancer. Yeah, good for this person, whoever it is. Here, more examples. So if you want to watch some of the images, feel free to just jump on the GitHub repository. What else? Border symmetry, border sharpness, for example, another one. So we use the fractal methods. We even recently published one paper, or actually wrote and waiting for it for the revision, about using fractal neural network, so a bit more complex structure that actually gave a really good results. So another one that we did, again, we just taking the region and then based on the number of colors, as you can see, we just change it to grayscale, and based on that, try to find out, get the borders, right? How sharp they are, or just measure the fractal method, fractal box dimension, for example, like linearity or other ones. All right. One thing that I would like to mention, because I have a few more minutes, is the black-white boxing when it comes to machine learning. Let me show you a simple neural network. Here, written in Python. 3 layers only. Very, very shallow neural network. Here, used on this data set, trained, as you can see here, accuracy 98%, super high, nice network. But if you print the weights, so the parameters that you actually train, right, that you train here in this part, of 1 layer, it looks like that. And now tell me which number is responsible for the prediction here. Which one? I don't know, really. That's the thing, that neural networks are black box methods. No one knows actually what are the parameters for. It is combined, and at the end we get the prediction. Compared to our decision tree here, using scikit-learn, it's similar, but you can get, for example, this kind of a tree. If you even don't know what's Gini index, because you don't care how it works in the back, then you can see, oh, if this value is true, then it's going here, it's false, and it's going here. So it's easy to move to from a decision tree to several if statements. So this is definitely explainable because you can show with your finger, for example, how to go through how actually the decision was made. So if you want to know more how to actually explain neural networks, because there are neural networks that are explainable. Oh, maybe I can show you. Here we go. What's here? All right, that's a dog. What kind of dog? Golden retriever, obviously. Right? So what we can do, we can build a neural network, quite complex, based on ImageNet, and do some prediction. Oh, it's a golden retriever with quite high probability, right? So other ones as well, but actually we see that it's definitely a golden retriever. But how did this neural network manage to tell us, oh, that's a golden retriever and not a, I don't know, a husky dog, for example, right? Or I don't know, a car, or I don't know, a human. Let me show you. This is how you saw that the neural network with 3 layers. Here, this network is a bit more complex, as you can see. And what you do, you take one of the last convolution layer and just build a heat map. It's called class activation mapping. I don't want to go into details, but this is how it looks like. So the call-out parts of the image are the parts that are responsible for the final prediction. So you can see the ear, the eye, the chest is responsible. The part of the image are the most important to get the prediction. All right, let me show you more examples. A cat or Maltesian dog, right? So you can see here in the back also it is bad if the background, for example, is the most important feature, right? For example, I don't know. I have a different presentation where actually I show how not to do machine learning, showing that actually some researchers do different kind of papers where actually the background, let's say between husky, where actually they try to find out if it's a husky dog or a wolf, and the prediction is just based on the background. Because wolves the pictures of wolves are made, I don't know, in the forest, on the snow, in the wild. Where actually husky dogs, on the couch, at home, in the garden, in the car, anywhere, right? But actually in the city. So the model didn't actually took the right features, to be honest. All right. Oh, if you want to laugh about the Ruby guys, I know Pythons don't. Anyway, if you want to see how not to do it in Ruby, there is a separate repository that you can find on my GitHub, how to do machine learning or not to do machine learning with Ruby. You can imagine they have a library called Pyko to invoke Python functions and libraries. How to do machine learning in Ruby? By Pyko, right? So invoking Python libraries from Ruby. I mean, they are still not so bad like JavaScript, but well, not the best one. Anyway, all right. Still have a few more minutes. Just to summarize, we used JavaScript as a part of the front end, but actually the model was developed using Python, obviously. So we have developed the model, then push it actually to the mobile app, and from the TensorFlow.js level, we loaded the model and then used the camera with this extension kit or other one. What's good about JavaScript? It works on different mobile phones. Well, it can be also easily moved. I mean, the model and in general the application can be easily moved from mobile phones to a web application as well. But well, the JavaScript community is quite huge. But when it comes to machine learning, it's very, very limited. So if you want to, if you're looking for an answer related strictly to JavaScript, you will find that. But related to machine learning in JavaScript, not really. When it comes to JS, there is a lack of MLOps support. Actually, there are no tools that I found that make sense. I mean, there are some few, but actually it's still same in Python. In Python, you have much more of such tools that helps you to actually deploy it to production, to make your data versioning and so on. Yeah, the community and thousands or hundreds of thousands libraries that are just not possible to use when it comes to JS. If you want to learn more, find me at YouTube. I had recently a TEDx talk about how to commercialize this scientifical. I mean, for example, my PhD, how to make it work, how to sell it. Really, 16, 17 minutes more or less that I did last year. Yeah, that's all. Thank you. If you have any questions, that's the right time to ask any questions. Still, we have some time, right? All right. Sorry for the images. I still didn't actually show you most of them, just a few. Any questions? All right.
Any questions?
Okay. Regarding MLOps platform, could you please elaborate a little bit more? How have you overcome the process of creating such a platform using Python?
Creating MLOps platform?
Yep.
Well, we use open source tools already available. Like we use MLflow, for example, right? I also now checking DVC as well for data versioning. So there are also several available commercial ones, like Neptune, for example. There is every cloud has their own actually solution for that, but we are actually more stick to the open source libraries. And this is actually what I wanted to talk about today. But I hope I can finish my presentation by the next meetup and then show you also the tools.
Okay, so hello. So as far as I understand, you are running the MLOps using MLflow.
That's one of the tools that we use.
Yeah. Give an example. You are recording an experiment, promoting it as a model, and then you are reading it using JS, right?
In this case, actually, we deploy it to the mobile phone somehow, and then actually using it on the phone with TensorFlow.js. Yes.
Okay, so the model isn't published as an API. It's on the application. It's a part of the application.
Both actually. It works on the cloud and also locally. So there are different kind of, let's say, pipelines to do that.
Okay, I see right now. Thank you.
Because as I mentioned before in one of the slides, it's well, the thing is that in many cases doctors don't have internet access on this device. I actually figured out when I actually was talking with them at the hospitals that in many cases they are just, you know, living in the not living in the basement, but they are working in the basement or actually in places. If you go to any kind of a hospital, in some places there's just lack of internet connection. So it's still good to have something that works here. In other case, they will be annoyed and they will just throw it away because they have, you know, plenty of other solutions on the market that are available. So we don't want to make them angry. If anyone is just give you one announcement. If anyone is parking here, just let me know so I can, you know, because it is closing at around in 5 minutes. So if you want to get your car and don't stuck here, just let me know before I leave. Okay? We have a parking here on the back in the company. You mentioned that you have problems with the data, actually. And I was around 10 years or 15 years ago, I'm a lecturer with Professor Lowas-Rzechonek. Yeah. This is my actually, no, yeah. And he described also the same story, like he has a problem with data. Mm-hmm. And you mentioned that there is an open database, but how it looks like, how it changed during this life. So it's much more easier to grab data because you mentioned only one person and one database. The thing is that can I repeat the question? It was quite a long one, but how actually to deal with the data in these days? You mentioned about Professor Lowas-Rzechonek. Actually, he is my supervisor of my PhD thesis. And yes, we had this problem from the beginning with the data. How it is in these days, you have the ISIC that is available. It's not for commercial use, just for a scientific, so that's bad. But because we started a cooperation with the company, the German one, so we had some licenses to data sets not available for everyone. So we have another one actually to work on. So it's just different. But it's totally different now compared to what was actually 10 years ago. There was no data, but it's good. I mean, the COVID, I know it's bad in general, the whole pandemic and so on. But one thing that is good about the COVID pandemic is the doctors are more open to collaborate. They are more willing to, they are willing to share the data compared what it was just before the pandemic. So that's interesting because now we have so many data. Our research lab is just, they have so much work, not only on skin cancer. We just do the coronary angiography, we do breast cancer, we do osteotomy, and different kind of other medical topics. That actually, it wasn't really possible to do it, I don't know, a few years back because they were not, let's say, friendly to actually doing any kind of cooperation. If you work with in general, yes. In general, yes. We even are now obtaining one for the osteotomy data set that we also got from one of the hospitals. And one of the papers actually is now, we send it to Nature to be published. Because it's very interesting how to calculate the correction angle. Osteotomy is a surgery of if you have this kind of legs to make it like that, right? And to do that, you need to cut part of the bone here below the leg, and you need to calculate the. You can imagine I was visiting the doctors and they showed me how they do that. They are just printing the X-ray on a sheet of paper, take the scissors and calculate the correction angle. How is that possible, right? So what we did, we have automated the whole process. And now it's calculating based on the X-ray. It's calculating automatically. So now they don't need to print. They don't need to use scissors. They just can put it to our Python app, and it works, right? So this is how it's changed. It's changed, and I love what's going on. What's happening now. So the question is if I use some pre-processing methods, right, for getting features. In my PhD, yes. In the production application, yes and no, because some of the method doesn't need to. I mean, the feature selection, feature extraction doesn't need to be actually, we don't need to do that because some neural networks doesn't need this part. So we just skip that. But in the past, we did that because we use shallow methods, and some of the models are also developed using shallow methods.
I have a question. How often, so as I understood, you collect data from and then how often do you retrain your model, and how often do you deliver this new retrained model to all devices?
So now, first of all, we don't care about collecting data anymore. Some other ones do that for us. That's great. Well, I don't need to go to every, dermatologist and grab some data. That's good. So we have the data already. At least part of it. I mean, huge part of it. When it comes to retraining, it's still a prototype that we are now developing. It should be there when we get the FDA approval. That's why I showed you the black box, white box methods, because if you want to get an FDA approval and actually have the tool on the market, delivered to the market, you need to have an FDA approval. And to get this one, you need to explain how the method works. You cannot deliver them like a black box and, it works with 90% of accuracy. We don't know how, but it works well. That's not something that you can do in the medical field. That's not possible. So you need to prepare a lot of paperwork to show how it works under the hood. There's an example of the dog, right? You need to take a picture of a cancer and tell, you see this red part of the image? This is how the method works, getting the features. And this is the feature, I don't know, the stripes, for example. This is one of the melanoma feature, anyway. And this is something that you need to show. So this is still a process. When the product will be released next year, for sure I will do another talk about that and show you in details how it looks like. Now we are testing that. We are testing also with the doctors. Also here in Krakow, there are a few that actually cooperating with us. So hopefully it will be next year, and I will come to you showing a brand new dermatoscope with AI with machine learning inside that works. And hopefully the doctors will like it, because that's the most important thing. Yeah, if you have any question about cancer, about machine learning, feel free to find me anywhere here. What else? Yeah, thank you for joining here at Techies. Also, thank you online. Sorry, you cannot grab a beer. We can. Still, thank you for joining, and enjoy. Thank you for now.
Thank you. And we're back on the streaming as well. So welcome back after a short break. And we're moving to our next presentation. Michał will change the topic from health to money, and we'll speak about money. And I don't know if I can give anything more than money about this introduction. So I'm giving the microphone to Michał. Let's welcome him with a loud applause.
Dobra, cześć. Halo, halo? Dobra, wszystko słychać. Cześć, jestem Michał. To będzie prezentacja z cyklu Zrobiłem rzecz. Kiedyś z kolegą tak sobie pomyśleliśmy, że skoro jesteśmy programistami i coś tam wiemy o liczeniu rzeczy, to może by coś policzyć na pieniądzach i może coś z tego wyciągnąć. Wszyscy wiemy, jak to się kończy, z reguły kończy się źle. W związku z czym zacznę prezentację od tego, co jest absolutnie konieczne na początku każdej takiej prezentacji. To nie jest porada finansowa, ja nie jestem doradcą finansowym, nie jestem doradcą podatkowym. To wszystko, co tutaj zobaczycie, robicie na własne ryzyko, jeśli zdecydujecie się to robić. Dodatkowo, to nie jest też porada techniczna. Razem z kolegą, jak robiliśmy ten projekt, tak? Oh boy, in English. All right. I'm gonna try, just for you. All right. So the first thing, I'm not a financial advisor. Investment bears risk. Don't do it if you don't know what you're doing. Hopefully, after this presentation, you're gonna get a hint of what this is all about. But I encourage you, if you want to try it safely. And also, this is not a technical advice, because when we did the project, we made some questionable design choices, and I'm gonna speak about them briefly. Nevertheless, the whole thing seems to work a little. All right, so let's start from the beginning. There is a thing called the stock market. Who has a brokerage account? Right, this is good. This is good. Right, so back in the day, there were some companies that needed money, and people thought, okay, so maybe we could sell a bit of the company we have to some random people, maybe find some investor that is willing to give us money in exchange for the profits that we're gonna make eventually. And how to find those people? Well, you can always go around and ask your friends, but eventually a more efficient way of doing that was invented, and this is a stock market. And how it looked back in the day, bunch of people gathered in the room, and one of them said, well, I have some part of the company I have, and I'm willing to sell that. And who's gonna buy? And they were just basically waiting for offers. Nowadays, this is obviously more automated and done better. You don't need to go anywhere, and you don't need to move paper around. Everything is held. Well, the whole stock market in Poland is managed by a company called Giełda Papierów Wartościowych. This is a private company, by the way. And all the paper that you move around is kept in a virtual account by another company called Krajowy Depozyt Papierów Wartościowych. So what happens if you want to do something with it? Well, first of all, you need a brokerage account. But the way the stock market works is that all the trading and stock exchange happens on sessions that are held pretty much daily from certain hours. And during that hours, you can ask a broker, makler. So this is a licensed financial professional that has the right to enter your bids, so your offers or your offers to sell or buy something on the stock market. And this happens on the spreadsheet. And the spreadsheet has basically two columns for every asset you want to trade. So for example, if you have a bag of potatoes, you can say, I want to sell this bag of potatoes for 100 zloty, and someone else says, okay, I need a bag of potatoes, and I'm willing to pay 80 zlotys for that. So those offers are put into two columns, buy and sell. They are sorted in an opposite order, and whenever there is a match, so someone is willing to pay the amount that the seller is asking or more, then the trade is executed, the bag of potatoes moves hands, and this event is called a tick, and means that at the moment the whole stock market prices this bag of potatoes for the amount that was matched. Obviously, because you do that, you don't do it yourself, you do it via a broker. The broker takes commission for that. So you need to pay the broker some percentage of the money that moves hands. And in order to keep track of all the transactions you make, you need a brokerage account. So yeah, these are the basics. Now, the whole idea to make money is to speculate on the prices. You, as a private individual, don't have enough money to do anything really to influence the business. Pretty much the only thing you can do, unless you're pretty rich, you can try to guess what the next price is going to be. So what you want to do is to buy something at the lowest possible price and sell it later. There are other ways, but I'm not gonna talk about them. They are not very popular in Poland. This is a really relatively small market, so no leverages, no shorts, nothing like that. Just buy something, wait a bit. Hopefully, it's gonna be more expensive when you try to sell it. Now, obviously, you cannot predict everything about the price, so you need to have some preparation that if the price is going down, it's going down too much, then you need to sell it as soon as possible to basically shield yourself from the losses. And because one of the things, well, you buy a bag of potatoes and it's going to be more expensive next month, but if you buy bread, it's going to be cheaper next month. So you need to trade different things. This is called diversification, and you really need to do that about your money everywhere. Like, don't keep all your money in one place. And the last thing that is really, really important, and this is the main topic of this talk, is that you need a system, a strategy. Because if you do that, if you trade manually, you are prone to errors, human errors. You follow emotions, you follow the news, you follow, well, your friend's advice, whatever you do. The best way to do anything about the stock market is to follow a strategy. You need a system that you're gonna develop yourself or take someone's system and basically execute it. So we thought, what if we take all of that and make the computer do the decisions for us? So we're gonna need a system that is going to tell us what to sell and what to buy, probably or possibly at what price. Then we're going to take those recommendations from the system, put them into the real brokerage account, make those transactions, pay commission and everything. We need this engine, or this engine, to have some knobs that we can turn to fine-tune whatever we want to do. For example, some people might be more open to risk, and some might want to be more conservative about their money. We want it to look somehow, because we want to look at pretty graphs. We want it to be reasonably fast, so that the whole thing is gonna be able to produce recommendation until the next session opens. So between closing on one session and opening on the next day, this needs to do the magic and do the recommendation so that we are ready to execute the trade on the next day. And we don't want to spend too much time on implementing that. But at the same time, we want to have some fun with coding. So what we started with is that the tools that we're going to use. To do the project, we selected the tools that we know. So first of all, well, there's going to be some data. So we're going to need a database. I can't do very much in Excel. I don't believe in NoSQL, and I hate Mongo. So we're going to use Postgres for that. Probably, and hopefully, Postgres is going to have enough mathematical things inside of it that we can use to do all the calculations we need. Then we're going to need some kind of UI. Back when I started, Django was my framework of choice, and I can't do UI. So we're going to use Django admin exclusively for everything. I'm not going to build views and do the front-end work. I hate it. Then we thought that, well, if this thing needs to do the computations daily, I don't want to open the page daily to do the thing. So it needs to have some kind of worker in the background. And in order to communicate with the worker, we're going to use ZeroMQ because I read a book that it's good. The book was fine, so I'm going to try it. And then, in order to show everything that the engine does, I'm going to use WebSockets because WebSockets are cool. And we're going to use Knockout.js for displaying all of that. All right, so these are the basic starting points. And right, so the first thing we did, we tried to assess how much data do we need to process. And there are a couple of problems with pulling the data from the stock market. In Poland particularly, GPW, Giełda Papierów Wartościowych, does not provide an API. But there are places, there are some broker houses that expose this kind of information later on after the session closes. You don't have access to individual traces during the session, but you can pull the report after it closes. And that's enough for us. There are some problems inside the data itself. For example, there is a thing called split and resplit. Basically, there is an operation that the stock company can do that makes one share that you own 10 shares at a tenth of the price, obviously, or the other way around. They do that to manage the volume of the stocks that move hands. Sometimes if the price falls too low, they need to do the resplit in order to increase the basic price of the share. There is the rule on the GPW that you cannot trade anything below 1 grosz, I think. The other thing is when there is some problem, like law problem with the company, the stock market can decide to stop the trade for some period. So you're going to have gaps in the data. And the last thing, dividends. These are the payouts, basically. The company can decide that it has excess profit and it wants to share that profit with the shareholders. So we made $1 million. We want to pay it out to the people who own the shares, mostly owners. But the law says that if you do that, well, okay, you have 50% shares, and you can take 50% of excess profit, but all the other 50% need to get something as well. And that's going to be us. So if you own a share and the company decides to pay out the dividend, you're going to get some money. It's not going to be much, but it's going to be there. So the question is, what is the volume of the data? And on GPW, it's not that much. The stock market in Poland started in 1991. So we have roughly 7,500 sessions from that day. About 400 companies. on the market. In practice, 250, because some of them are not traded that much. So we want to pick those 250. So we end up with roughly 2 million records in the database. This means that all of that fits in memory. You don't need to worry about big data or anything like that. So let's start with pulling the data into the system we have. So we find a broker house that exposes the data. Typically, they do that in CSV. From the beginning, there is a zip file available on Bossa, I think, one of the broker houses in Poland. You can download it, and it's a zip file with every session from the beginning of the world. And we need to pull that into our database. How are we going to do that? I played around with importing the data, and it turned out that doing manual inserts in SQL is just too slow for my patience. So we did it in a smart way. We create a temporary table in Postgres. We copy the data from CSV directly into the table, then pre-process it in order to fill the gaps, those gaps caused by stopped trades. And then we spread the data to the final tables for analysis. How do we do that? Well, this is a piece of Django code that does exactly that. So we create a context manager that creates a temporary table. Nothing really fancy. And then using that temporary table, we execute a copy operation. This one here. This is a clause in Postgres that allows you to pull a CSV file directly into the table. So we do that, and it's pretty fast. Then we run a query to fill the gaps. We assume that whenever the trade is stopped, well, in the source data, you're going to get nulls. So like the company you are thinking about is basically not traded at all on the given session. And we're going to pretend that it actually was being traded and the price didn't change. And the volume was 0, so nothing moved. So I wrote a pretty big but basic SQL window query to fill in those gaps. And then we move that into the table in raw SQL. One of the questionable design choices, but it works. Then we want to show it. So we ended up integrating a JavaScript library called HighCharts in Django admin. And in order to move the data from the database into the library, instead of providing a REST API that exposes all of that, we just render the table directly into SQL, building an array, and then plot this array. And we ended up with a UI that shows you, okay, what was happening, right? So you have quotes, you have prices for each day, and some kind of plot that you can browse. That's the start. Now, question is what to do with it. There is a thing called technical analysis. Basically, it's divination. The theory goes that if you look closely at the graph, you're going to see patterns in there that's going to tell you what's the next move, whether up or down it's going to be. In my opinion, this is all bullshit, so don't bother with it. It basically doesn't work. What does work, on the other hand, is an interesting anomaly that is statistically proven on the stock market. And it says that if the price is moving up for some period of time, it's going to keep moving up. but it moves too long, then it's going to start falling down. On average. The question is, how long are those periods? And we found out during some experimentation that this period is about 3/4, something like that, a couple of months, basically. So based on that, we're going to try to devise a strategy that hopefully will earn us some money. So once in a while, because we don't want to spend our days staring at the screen, pick some stocks that exhibit this anomaly. Like they have trends. They are going up. And we're going to buy the best, like the ones that are going upwards fastest. And we're going to diversify. So we're not going to buy one. We're going to buy a couple of them in order to shield ourselves from the risk of one of them going down, which might happen. And we're going to avoid trading things that are hard to sell. So if there are some companies that are not traded very often, we don't want to buy them because we're going to have a hard time converting them to money later on. And then what I spoke about previously, if the price is falling down too fast, sell it immediately, like get rid of it and prevent other losses. And the last thing, we don't want to pay too much commission. So we don't want to execute too many trades because every time you do a trade, you need to pay commission to your broker. So ideally, trade as little as possible. So the first thing that we need in order to execute the strategy is a thing that technical analysts call an indicator. And in our case, the indicator is a rate of return. So how much it's going to give you back if you buy now and sell in 3 months, for example. And we attach this information to every session and every stock in every session. And to make our lives easier, we calculate that on a database side using annotate. So we're going to just build a table that says that on the given session, this and this stock would give us returns of X for the last 3 months, and so on. Like 3 months, 4 months, 5 months, and so on. Right. And when we do have that, now comes the interesting part, how to do the engine. The basic idea that we had is that we're gonna take all those information about sessions and the prices in each given session, feed it into the machine, and the machine is gonna do some computation and produce a set of things. First of all, the current status, so the overall rate of return, for example, for the whole portfolio of stocks that you have. It needs to produce a graph, so we need to know how the value of our portfolio changes over time in order to plot it. It's going to produce recommendations, so those things that you get on your email saying like the machine says you need to buy this and this company right now. And in order to test the performance, sometimes we want to run it in the automatic mode and tell the machine that it's going to try to execute the transaction really, like, as if it happened, kind of a playground. So how to do this? Now enters 0MQ. A bit of intro. 0MQ is a protocol that runs on top of TCP, kind of. And it provides an abstraction on top of row sockets. So it does the bookkeeping for us. It automatically resumes the connections, and it provides the framing protocol inside the connection. It can run on top of different transports. For example, for some reason, it can be used to communicate between threads in the same process, if you want. It can communicate with other processes running on the same machine, or via TCP on different processes running on different machine. And those endpoints that ZeroMQ called sockets are the same as TCP sockets. Like they have the same semantics, just automated. There are different kind of sockets that you can connect together to achieve different results. So I'm going to talk about that in a second. And as of the protocol provides the framing, and each message inside the protocol consists of a couple of frames. And those frames have meaning depending on the type of socket that you want to use. This is all very, very low level, but useful. The kinds of sockets that we are interested in is, first of all, request-reply pattern. So this means that you have a server that exposes some kind of endpoint. Well, this is basically RPC, right? You have a server that exposes some kind of endpoint, and you allow clients to connect to that endpoint and execute an operation, like send a message and get back the reply. And that's it, nothing more. The limitation here is that you can have only one client connected at the time, which for some applications is fine. There are other variations of that pairing. Request router, meaning that you're going to have one server that can serve multiple clients at the same time. And the other way around, dealer reply, when you have one client that is able to connect to a couple of servers. And the other interesting pairing is publish-subscribe. So you have a server that exposes a pub socket, and you have a client that connects to that and says, okay, dear server, I want to subscribe to a certain key or topic, and I want to receive all the messages that you produce related to that topic. And this is where the framing enters. The key is the first frame of the message, and the rest is whatever you want. How does it work in practice? In our case, we have a server that produces data about sessions. So we have a CLI application that tells the server, okay, dear server, so you have all the history in your database, but I want you to produce a stream of sessions as if it was the 1st of November, and I want you to publish those 3 sessions to whoever is listening. And we're going to have an engine, the client, sitting here, subscribe to that data. And this way, we can tell the machine to dial back the time and execute those trades as if it was some time ago. Then there is a thing called cloning. So if you have a client that wants to plot some data that is changing in real time, like the balances, like we have a stream of balances, so basically valuation of your portfolio over time. And if you want to plot that and update that in real time, you connect to the socket that publishes the changes, but then you have a problem because you receive only the new updates. And you can plot from now to further on. In order to plot everything earlier, you need to ask for the history. And ZeroMQ book proposes a way to do that. And the way to do that is that the server needs to expose 2 sockets. One, to get the current state and all the history, and then the other to stream updates in the real time. When you have that, you can then have the client be a bit smart about the way it works. It's going to connect to the updates and start receiving new values. And then while the new values are being streamed, you're going to ask for the history, merge the two sets, and only when they are merged, you can show them and start updating real time whatever you receive. And then the last thing, in order to feed all of that into the browser and our Django admin UI, we need a JavaScript library that can do that, and a bit of proxy code that can take the WebSocket connection, turn it into a 0MQ protocol, and talk to our server. And this is how it works. Like, we have a WebSocket server that accepts connection on the URL, then does the magic to convert the WebSocket framing into 0MQ framing, talks to our server, whatever the type of the socket, and then sends back the messages. All of that is transparent and doesn't really care about the type and address of the socket. And this is how it looks on the client side. This is the client that executes the clone. Yeah, that's basically it. You have a subscriber and dealer. Dealer is the guy that takes the history, and subscriber is the one that receives all the updates. And this is the important part. When you this change here is like important, right? So you start really updating the state and the graph on your side only after you receive all the history and you process it. Then, after we receive that on the JavaScript side, well, in order to show that to the user, we need to update the UI dynamically. Krzysiek recommended Knockout.js. It was his thing at the time, so we use that. Why not? This is a library that allows you to move variables on the JavaScript side. Whenever the variable changes, the HTML in place is updated. I like it because it's not intrusive. You don't need to build the whole page around it, like in some frameworks. And we integrated that with Django admin. It was pretty easy. You just you provide the template, and then in the place in your HTML, like regular Django template file, you enter that KO template, and then render whatever you want to do. So this here, when expanded, inserts that here, because summary widget is the name right there, and binds that with a variable called summary. This is in a JavaScript object that has fields like total, stock, cache, and so on. So whenever the properties of that object change, the UI is updated automatically. Yeah, and this is how you do the updates. So you need a variable called summary, some kind of object that has properties. And whenever you receive the message, like in the code that I shown later, this is the callback function. You just set the value of the attribute to something. And then you run knockout on whatever the page you have, and you end up with the UI that updates automatically. So this is actually a part of UI that those numbers all change whenever the engine is running. Right, so the most important thing, the demo. Hopefully nothing is gonna break. So this is Django admin with all the things. Starting with the database, the visualization. These are the sessions. So if you take yesterday's session, these are the companies that were traded yesterday. The prices, how much changed hands, and those are the indicators. So rate of return for 60 days, for 120 days, and so on and so on. And then this is the average volume for some period. We use that to filter out things that are hard to sell and buy. So if the average turnover, the average volume is too low, then you don't want to buy that because it's going to be probably hard to get rid of it later on. Right? Oh, and high charts. This is the brutal way of rendering that, but yeah, well, that's the graph. Nothing fancy, you can find all of that publicly. It just shows that the data we have is there. And this is the engine. We say here, these are the lists of transactions that the engine automatically executed. We started with giving our broker some cash, 50,000 in this case, some time ago. And we say that, well, this is our portfolio, and we want to trade every 90 days, so every 3 months, basically. We don't want to look at it too often. We want to run in the automatic mode, so it's going to execute the trades on its own instead of sending recommendations to us. The commission that the broker takes is roughly this, but no less than not less than 3 zloty for each trade. We're going to sell when the price of the asset falls below 85% of whatever we paid for it. And we are interested in return period for 180 days. So those 3 quarters I talked about. And we want to keep roughly 5 stocks in our portfolio because we are retail investor, we don't have too much money, but we still want to diversify something. And whenever you enter those things and run it, the whole machine starts, and you're gonna receive those updates via 0MQ, and you're gonna see how it would trade if it was a couple of years ago. The gray line is the total value. The orange line is how much of that is held in stocks, valued like they are valued on that given day. And this is the raw cash. So cash doesn't change value. This ignores inflation. Well, it does. And you see here the updates that are appearing in real time. This is the rate of return for the whole trading period, and this is the rate of return for 1 year. This is like a statistical value called compound annual growth rate. So meaning you would get this if every year you traded, you ended up with this return value for a year. So this is like a yearly return. It's pretty good. 30% is pretty good. I would expect something around 8% is like the top return value that you can get, really. The average global product raises about 4% a year. So anything beating that is really beating the market. So you are better than the global index, like the global economy. If you are better than the global economy, then you're gonna earn money. So that's it. Right. So that's basically it. And here you can see the list of trades that were happening, or maybe expand that. So for example, here the engine said that we're gonna buy this and this company, this amount for this price, and we paid this commission. If you run that in non-automatic mode, maybe I'm gonna show that. For example, you can pause it. So it's gonna start. Oh, it's not paused. Right. Right. It's because it executes everything from scratch. Let's wait until it finishes, and I'm gonna show you how we debug this thing during the operation. Because in the background, it executes well the strategy, so the code that decides what to do and what to say. It used to fail a lot, and it's really hard to write tests and debug it, mostly because we have no test for that. And we tested everything manually. And we tested it manually by pausing, like here. So I think if you do it this way, right, you're gonna end up with the beginning. So this is the first transaction that the engine did. It bought some stocks, and the portfolio is paused. Now it waits for the requests on this request reply socket, and your browser can tell the engine to move to the next session, to the next session, to the next session. So you can basically debug it and step through all the history. And if you keep clicking that, I think it should start plotting something eventually. Or maybe not, because it broke. It doesn't like me very much tonight. All right, it started plotting. Right, so whenever you click, the database produces a next set of sessions to the engine, and the engine can then decide what it should do, and does that. Right, and that's it. I think I use it, and I'm not gonna tell you how much I made or lost. Thank you.
Do we have any questions? The microphone is running now.
Thanks for the presentation. I'm going to open with a very simple question. How specific to giełda papierów wartościowych is this? Like how applicable it is to other markets if you want to use the same solution but just feed it with the data from different stock market?
Shouldn't be too brittle, although the thing here that is a bit problematic is performance. Like it's not very fast, as you've seen. The graph is not plotting in real time as I hoped it would be. I imagine that if you want to pulling the whole history from the Polish stock market takes about 10 minutes to import that into database. 2 million rows is nothing much. It's not much. But if you try to do that for the American market, that's going to be significantly more. They have more companies, and the stock market was operating for far longer. I haven't tried it, so I don't know.
Hi, thanks for
that being said, nothing here is specific to Poland.
So this 13% you showed, is that the 13% of 50,000 that was in example?
Yes.
Yeah, plus 13%, all right.
Yeah.
So you're saying that this is run on live, could that be run on live data? I mean, in real time, this program?
Yes, it is. Yeah? It is running in production, like on my server. It is running on live data. It fetches the newest session daily, and runs the strategy on that. So every day, every trading period, so every 90 days, I get an email from the systems telling me to buy this and sell that.
So it's not cashing the money directly to your account?
No, right. That's the other thing. The banks and the brokerage houses, they typically also don't provide an API for individual investors, probably for a reason. Like if I plugged that in directly to my bank, I would be very, very uncomfortable. This is code. I don't want this code near my money.
Right. And maybe the last question, is there API for instance, US stock market?
I believe so, yes.
Well, you could use that one too. Why did you not use API
In order to trade on the US stock market, you need a brokerage account there, and I don't have one.
Cheers.
You know you don't need an API. You can use beautiful Zoop on your bank account.
Yeah, you really want to do that, and then bypass two-factor authentication too, right?
Exactly. Any other questions?
Hi, I have a question. Did you encounter any overfitting problems with the algorithm? And if so, how do you resolve them?
What kind of problems?
Overfitting, the overfitting when you are testing on historical data and the algorithm becomes expert in historical data.
Right, yes. That's one of the disclaimers. Past performance is not an indicator of the future performance. So whenever you do...
Do you have any, any tests how it does on the future?
The only thing, in terms of performance, like the rate of return, it relies on the existence of the anomaly I described. So this is the only thing. If the anomaly doesn't happen anymore or is proven false, the whole thing falls apart. So
Okay.
I'm just exploiting a glitch in the system really here.
Okay, thanks.
Okay. Any other questions?
Maybe I missed that, but did you use any machine learning libraries in here?
Probably, but I would be cautious about that.
What did you use?
For those reasons.
All right.
I didn't. What we did, we tried to find the optimum parameters for the strategy I described. So the strategy says buy something based on the estimated rate of return, then wait a bit, then sell it. And the question is how long those periods should be. How long should you trade? The time between trades should be, and what period of the rate of return you want to take into account. And we ran a discrete optimization engine on that called Nomad. It was made by Bain, I think, on some kind of French university. And it basically on the backtesting training on the historical data, it confirmed the existence of the anomaly I described. And that's the only hard evidence I have.
Okay, thanks.
Okay. Any other questions?
Thanks for delivering the talks in English. And I want to ask, do you think that maybe using instead of Postgres, like a columnar database for an analytical database could improve the performance of the reading and writing of the data? I'm speaking about I don't know, HBase or Cassandra.
I didn't catch that. Please slower.
Sorry. Have you tried any columnar database like Cassandra or HBase, which are supposed to be faster?
It would probably the problem here is not really the database. The database for this volume of data is reasonably fast. There is nothing bad happening on the database side. The slowness that you see comes from the communication overhead. So how much time it takes to move the data from the database into the engine, basically. That's probably because Python is not a very fast language in those areas.
Okay, thanks.
Okay. Any other questions? All right. So thanks a lot for your presentation.
Thank you.
So now we'll have I think 2 minutes break. So a very, very short break. Just grab something to drink, go to the bathroom if you need to, and we'll start setting up the lightning talks. And straight after the lightning talks, there will be a competition and finalizing the meeting. And then we're moving to the after party. And who is going to attend to the after party? Yeah, that's much better. Yeah, that's what I was talking about. Okay, so just 2 minutes and we're back with the lightning talks.
Let me then start the presentation. Okay. So, hi everyone. My name is Vasilis, and I'm probably one of the reasons that we have this meeting today in English. But thank you for that. I appreciate it. I'm a site reliability engineer at Sabre. I live in Krakow for about 4 years. I still don't speak too much Polish, so sorry for that. And today's presentation, it's kind of a small demo about Python, but not in a conventional way as developers use it, but in a sense as a tool or a means of convenience for people like me, who I'm not a developer. I consider myself more of a Python user rather than Python developer, to make my life a little bit easier. So this is part of what Python can do for me and other people like me. So basically, what we're going to do today is use a cloud platform, Google Cloud, and a PubSub component or a PubSub service that Google Cloud offers, and use Python as a way to interact with that service. Well, I believe most of you are familiar with what a PubSub system is, but since I don't have too many slides to show you, I'm going to say a few words about PubSub anyways. So basically, this is what a PubSub service more or less looks like. There are two main components, a publisher and a subscriber. And basically, what happens here is a publisher is the entity application that creates some messages and sends them into a topic, all right? And these messages are stored there until it is acknowledged by subscribers. And when we say acknowledged, we mean that subscribers read the message and they acknowledge to the system that they have read them. And for a subscriber to be part of it, needs to create a subscription to a certain topic that a publisher sends message to. And there are two ways of achieving that. And it is either by pushing or pulling. And when we say pushing, it means that the publisher is pushing the messages to the subscribers, or alternatively, a subscriber is pulling the messages that the publisher is storing into a topic. And the last part is that once the message is acknowledged by a subscriber, it is removed from the subscriber backlog and it's not read again. And there are different models in a PubSub. So you can have multiple publishers sending messages into a single subscriber, which can be many to one. One to many, it is the other way around, that we have one publisher and multiple subscribers reading from that publisher. And then the many to many, which of course is multiple publishers create messages into, I guess, one or multiple topics, and subscribers subscribe to either one or multiple topics and read the messages that are published. And this is what our demo is going to be about. By the way, this demo is not made by me. It's available in the Google Cloud documentation. I just stole it and presenting for myself. So basically, what we have here is a topic that we've created in Google Cloud and two subscribers. So we have one-to-many model here. So one publisher creates the message and the two subscribers are just waiting to receive the message from the publisher. And the interesting thing about pops up here is that this communication happens asynchronously, which means that subscribers do not need to wait and listen for the publisher to create the message. Publisher can anytime publish any kind of information message in the topic, and each subscriber is responsible of reaching out to the topic and pull the messages that have not been acknowledged yet. Remember that once a subscriber reads the message, it's removed from the backlog, so it doesn't need to read that message again. So every time the subscriber is trying to pull, it will pull only the messages that have not been acknowledged yet. And with that being said, I guess I will just move now to the demonstration. And yes, so perhaps I will do it in that sense. Let me clear a bit. Is it visible? All right. So what I'm going to do first here is start the subscriber application first. All right, so we have now the subscriber listening for any messages that the publisher will create. And on another window here, I will start the publisher. So the way this script works basically is it reads the project variable, which refers to the Google Cloud project. This is the first information that the application requires. The name of the topic, which I named as demo topic. And basically the last part can be the message that I would like to publish. So I'm gonna type here, hello Pykonik, and I'm going to publish it. So as you can see, I get the message that this hello Pykonik has been published to my project, which is this pops up demo, and it's stored under the demo topic, and it has a certain identifier, as you can see in the end. And this identifier is of course a way to distinguish each individual message that's being published. And if we move back to the other window, we will see that already the subscriber has received this message and has acknowledged it in the bottom, the last line. So has acknowledged the message with the specific identifier. As you can see, it's the same. All right, and unfortunately I wanted to do this side by side so you can see it happening live, but the font here is not on my side. So what I'm going to do now is I'm going to paste something else. So I'm going to provide something like this. So this is another message that's been posted, and shortly after we see it again on the subscriber. And what I'm going to show you now is the thing that I talked about a few moments ago, about how this pops up mechanism works in a asynchronous manner. So what I'm going to do now is I'm going to start the second subscriber, because if you remember, we created two subscribers that are subscribed to the same topic. All right, so and I'm going to do something else at the same time. I'm going to stop the first subscriber, and you are going to see why I'm doing this in a moment. So I'm going to kill this now, and I'm going to start the second subscriber. And as you can see, now this is interesting because as you can see, once the second subscriber starts, it pulls and reads all the messages that have not been acknowledged yet. The first one that you see, or maybe the last one that you see, is something that I was trying before the presentation, and probably second subscriber didn't get the chance to read it and acknowledge it. So now that I started, it pulled it alongside with two messages that are created right now. And this is why you see 3 instead of 2. And now what I'm going to do is I'm going to create one last message. I'm going to publish one last message, which is going to be this. And shortly after, it appears on the second subscriber. And now, after this, I'm going to start the first subscriber. And hopefully, you will see that the first subscriber will just read the only last message that I created now and not trying to read the messages that have been acknowledged already. So as you can see, this is exactly what happens. And yeah, and this is a success because this is what we expected. So I'm going to stop this subscribers. And at this moment, I just like to show you how it looks on the inside. So we're just going to digest. Before I do that, yeah. Okay. So I guess that's it, because this is what I wanted to present anyways. Right. So that was all. Thank you.
That was great.
Okay.
Arthur? You just need this one? Yes.
I think it's good enough, maybe. Just this. Okay. Following up on the Vasilis presentation, I'm pretty sure like if you give him another round of applause, he will be happy to do a full-length talk on the next Pykonik. So, yes. And since you're here, you probably like meetups. And I'm going to announce another meetup that is already on meetup.com, which is going to happen here on Tuesday, November 29th. I'm not sure if you can see it. Let me just try to make it a little bit bigger. So Tuesday, November 29th at 6:30 p.m. So it's 18:30. If you like the talks today, you will also enjoy the talks from the PyData meetup. One is going to be about IoT-enabled litter box with machine learning, and about peering beneath the surface of the Earth in the clouds. This is, well, I can probably read the description so you'll know exactly what it is about. So, yeah, it's just like this meetup, but on Tuesday. So see you there in 5 days. Okay, that's it.
Okay, and we're moving to the competition part. never mind. Okay, so actually we'll start with a few slides so that we can say a proper goodbye to everyone who is watching us on the stream. So we're nearly at the end of the Pykonik 59. The next one, Pykonik 60, would be probably on the last Thursday of January. We'll try to keep those dates, so you can already save the date. Just wanted to remind a bit of a thank you. Thanks to Kodete and Techies for hosting us today. They deserve a round of applause. Thanks to Talixo for having beautiful prizes for the competition today. And thanks to Clark for hosting the streaming today. It is a great work that you do. And if you want to find us, the first place where we host all of the information about all of the meetings is pykonik.org. Every meeting is there. Right now we've started to have simultaneously coding dojos. We usually try to have one dojo every month and one Tech Talks every month. So feel free to follow it on the pykonik.org or on the meetup, because we also post all of the information on the meetups. And if you want to be really close to the information, just join our Discord channel, and there are even more announcements there. And just small announcement, we're looking for speakers. If you have anything interesting to talk about, feel free to submit a proposal on the pykonik.org page. And now I would like to say thank you to everyone on the streaming. We'll be ending that, so thanks for being with us. And we're moving to the